And since most components over here are off-the-shelf components, this is very much repairable. Very much repairable. Hello friends, welcome back to the bench. Today we're going to take a look at the DCM from 2016 Subaru Forester. And now, what is the DCM? I actually didn't know. A lot of people wrote me asking about DCMs. And I had to check what exactly it was. So apparently it's a communication device. It has 3 antenna outputs, right? And this connects to the car. There's a built-in battery, and apparently in the event of accident, it communicates with the satellites or the cellular network. I'm not sure. There's plenty of antennas, so it probably uses cellular network as well. But what's interesting about these devices is that they fail. Apparently, they fail a lot. And you probably had, if you're watching this video, you probably had an issue with your DCM. And what do mechanics do? They just disable the DCM by removing the fuse. And you drive without this until they get the replacement. Because what happens with these, they catch a short, and it's basically a parasitic draw. So your battery dies overnight or after 2 days of not touching the car. It's not a good thing to have. So I figured I'll buy one of these. This one's from 2016 Forester. It cost me about $50, a little less than that, I think. Okay, so there's just 4 screws over here at the bottom, right, and 1 screw over here to disconnect the battery. This is what you need to do first. I already disconnected the battery, so that's why I'm not doing it. So the battery is 3.2 1100 milliamp hours, right? One big lithium in battery. And now, after removing 4 screws, we have access. Actually, this comes as a whole when you unscrew it, and it's not glued. It's thermal conductive paste, or well, not exactly a paste. Take a look at this. And it conducts heat to this piece of aluminum, and this is basically a heat sink. The board looks something like this. All the components, as far as I could tell, every single component on this board is pretty much off-the-shelf component, meaning all of them are available at Mauser, even including this MCU. Obviously, you can't replace it because there's code inside it. So replacement wouldn't fix your problem if this is what is shorted. I doubt it would be, but possibility. And so this one's not exactly replaceable unless you can get the software for it. But every other component, as far as the power, is replaceable. So let's take a look at it and see what could fail. I actually have an idea what can be failing on these.
Good morning, Papa.
Good morning, Archie. Okay, tiny interruption. So what I noticed immediately on this board, other than off-the-shelf components, because obviously there's nothing wrong with that, and I actually appreciate that because that makes the device a lot more repairable. But you immediately see the difference in quality. And what do I mean by that? well, there are no markings for the components, right? Let me grab something to point, maybe tweezers. All right, take a look at these resistors. All right, the way everything is soldered, and compare it to resistors on the ECM, right? First of all, we have a mask around on the entirety of the board, right? It might not be necessary for it, but that's how ECMs are treated, and pretty much all the electronics that go into your car, they're covered in mask. Check the quality of these resistors, the printing on them, the quality of soldering, right? This one is a lot different when it comes to quality. But I don't think that is the issue, because what happens to these, they cut short, right? They start shorting. So what we're looking for are, or what we're mainly interested in, is the power supply side. All right, this is our main coil, and that delivers, I don't actually know how much, but around 5 volts probably. And we have big caps, and we have few transistors. This is Q50P04, so that's 50 amp 40 volt P channel MOSFET. I checked pretty much, not pretty much all of them, but plenty of components over here, and as I said, they're available at Mauser, and you can read the data sheet over there as well. This, you can barely see it over here, especially with this lighting. That chip is a max chip, 16958 or 935. Also available at Mauser. And this is a chip that drives, we'll open this, but it drives at least this coil, I guess. It has 2 transistors built in, 2 MOSFETs built in, and it's basically for creating a power supply. It's pretty much the majority of the power supply in one chip. And how is it cooled? Well, if we flip the board, this is where it sits on the other side of the board. We have a little bit of this thermal conductive paste over here. Let me get some focus there. Right, you can see like some kind of crystals in it. Let's hope it doesn't conduct, because take a look at this. All right, that probably shouldn't be done this way, because there might be something conductive in it. Right, it shouldn't be sitting on the components like this. That's never a good idea. But this, the other side is where our max chip is. Right, we have plenty of vias, probably for the ground. Right. Yeah, this stuff is nasty. Probably vias are for the ground, but not necessarily. So what does that tell us? There's one spot over here and 2 spots over here, which probably should be 1 spot. And that, again, we have this components covered with it. Probably not too good. So the board, or the component, heats up on this side, right, our max chip over here, it heats up on this side, then it uses the board to conduct the heat to the heatsink, to our, whoa. So I'm not convinced that this is terribly great idea. And you can kind of see in those nearby components, like this one, it looks like it's been overheated, right? There's slight discoloration on some of these, but not on these. These look good. This one seems discolored. So it's hard to say because I don't know how much heat does this board produce, right? Without that information, we don't know. Maybe it just heats up to 50 degrees Celsius. So the sinking that heat is not an issue. On the other hand, it looks like the designer spent some time on the building, the heat distribution route for those areas, two areas pretty much. All right, let's look at the board again. All right, so these are these two. Did I already lose my tweezers? I did. These are those two areas that conduct heat from these components. It doesn't sound good to me that the board is used as a heat transfer, for the heat transfer. So the entire board, so this side, the chip is always going to be a lot hotter than this side of the board, right? What would be the reason against either placing that chip on the other side and allowing a heat sink to touch the actual component that heats up, rather than putting it on this side and using the board to kind of get rid of that heat, or to transfer that heat to the heat sink. But then again, we don't know how much heat are we talking. However, what we can tell is that this coil is pretty big. We have 330 mics on the input and output of that coil, and we have another 220 over here. This can deliver quite a few watts. We can probably calculate it, just taking the size of the coil into consideration. It's pretty beefy coil, pretty beefy. So this at right frequencies, it can deliver a lot of power. We have 4 relays over here. I don't know what they control. They probably allow the power from the car to flow and recharge the battery, perhaps. Here we have the actual communication module. It has its FCC number and the IMEI serial number, all that stuff. Alright, so this is what actually communicates, and 3 antennas connected to it. There's another shielded components underneath there, and obviously the shield for the main power supply, or at least that's what obviously knowing that there's a max chip over there, this is power supply. So we're gonna take off this shield, see what's underneath. Then we're gonna take this shield off, see what's underneath. This one's probably just this one's probably not soldered. No, it is. It looks like it was spot welded, because there's these punctures over here. Oh, you can't see, of course. Let's look at it from this side. See those punctures on the side? there's punctures on the side, so maybe it was spot welded, or maybe it'll just maybe we can remove it, but by just flipping it off. We'll see. If I have to break it to find out what's underneath, that's what I'm gonna do. But I'll try to do it without actually damaging the device. I would like to connect it to power and see how much power it draws, but it probably communicates on CAN bus, so I probably won't be able to fool it to actually turn on the radio and start consuming the maximum power. But even the standby power, we'll see whether it actually heats up or not, and how much heat are we talking. Because maybe I'm wrong about this. Maybe it produces very little heat and this is not even necessary. But what we do know about these devices is that they fail. They fail a lot. And number one reason looks to be quality that it's made, quality with which it has been made, quality of the assembly. You can tell, so obviously each one of these components are placed by a machine. No one places them by hand, right? But after it goes through the reflow oven, it comes out. Some of the components are not soldered correctly and they need to be touched up by a QA, right, after the board comes out. And you can tell which one these are. Like this one is slightly misaligned, right? So this one probably was resoldered. We can also see the soldering is different over here. So this didn't come from the reflow oven. And there's quite a few components that are slightly misaligned, and that would probably be the reason. I actually learned a lot about this process from the 8-bit guy. He worked on the Commander X16 and released like the behind the scenes videos of how they make those boards and stuff and what problems they're facing. One of the problems is warping of the boards. You need pretty stable temperature to get this done properly, to get this done without manual resoldering or manual touch-ups afterwards, and that obviously hinders the speed at which you can produce these. So that's not uncommon to happen, but it can, if there's a lot of them misaligned, and actually I can see very many of them right now, but I've seen this one's misaligned, right? And also, yeah, this is you can see the flux over here, right? So this has been resoldered afterwards, after it came from the oven. See the flux? Yeah. So this was fixed after it came out from the reflow oven, from the production line. So we can tell that the quality of production is relatively, well, I don't want to say low, because how would I know? But it's definitely lower than ECMs. So this is number one suspect, that the quality of the board will cause it to fail. The second suspect we have is the heat. The heat transfer is through the board, which could cause it to fail. And my money is on the max chip. If it overheats, it will obviously oh, I ran out of room on my camera. That's fine. Okay. What was I saying? The heat. If there's a lot of heat, the components will go short, especially transistors, MOSFETs, and stuff. So let's take off the shielding. Let's see what's underneath. and go from there. Alrighty, so the shield is off. I actually it seems like I took a little bit harder route to do it. So I figured I will wick it first and then use Heather to remove it. That usually makes it easier, a little more time consuming, but you avoid any warping to the shield because you then have to put it back on. If it's warped when you're just heating it up and pulling on one side, then it's just gonna deform a little bit. So I used wicking, but to use wicking I had to actually maneuver my iron. I had to remove the charging port and these two relays. And this was actually much harder than I thought. And I definitely damaged the exterior of it. It should still work, but in this case I would just replace these. They're available on Mauser, so that's not an issue. I bet this port is also available. It looks like everything on this board is available. Anyways, I wicked it, I removed the solder around, and then I used Heather. I obviously put the Captain tape on these two capacitors so I don't explode them. They don't seem dry and they're reading pretty well, so I was worried that they would explode. Now let's see what's underneath the shield. We already saw that Max chip. This one. No, not this one. Yeah, this one. Yeah. It's just the lighting is just off. Let's see the different angle. Like so. Max 16935. Alright, so that's the heart of our power supply over here. This shield actually, if you were thinking of not putting the shield back on, the device probably won't work correctly. It's very important. The size of these holes are, it's pretty much the same principle as you have on the microwave, a little mesh. It's not the actual glass on the microwave that stops the microwaves, it's that mesh. The size of the holes is calculated to stop the radiation of certain frequency. This one is designed for obviously a lot lower frequency, and it allows the rest of the device to work. Otherwise you will have terrible interference from the power supply. So the output caps are ceramic. We have 4.7 microhenry coil. This is likely a diode since it's on the output and it's connected to the coil, but I'm not sure. Here we have another chip and another coil, so this likely also produces some voltage, and more ceramic caps. So there's like almost nothing here. There's two additional transistors here, and just a whole bunch of discrete components. Actually, with the removal of the shield, I used something like this to kind of lift it, and while doing so I moved some of the components, this resistor, and I think I moved one of this one, right? So probably the best place to start would be here and just pry it from over here, because there's big components here, big cups, and you have pretty good entry point over here. As you can see, I even scratched a little bit of protective layer doing so, but I didn't do any damage. I wasn't worried about damage because you know, this board is mine. I don't mind breaking it. I just want to assess the repairability of it. Okay, so this looks very accessible. So anything over here, what would I expect? Probably I wouldn't expect shorts on these caps because they're covered by the shield, and usually when those caps start shorting, it's because of the physical damage. Usually, not always. I would expect this guy to be shorted, and there's two transistors inside, two MOSFETs, and the heat sinking or the heat distribution goes through the board, so I would expect it to get short when it gets too hot, and this one's probably the equivalent. I'll look for this. I'll look for the data sheet for this one. 78482 AG986. Looks like it's pretty much the same. Some kind of IC that produces voltage, because we have coil connected to it. No diode though, so it might have internal diode, and the output caps over here. So this is likely our output. Well, maybe hard to say, but plenty of caps on here, so this might be our output. We have 6 vias over here, so that usually means a lot of current is gonna flow. Alrighty, the next one would be probably this transistor. Definitely check this one for shorts. I wouldn't expect those little transistors to go short. This looks like a this actually looks like a BQ chip, but it's obviously it's not. But it probably is some kind of power management chip, I would guess. But again, this would be simple to diagnose for shorts. And I would just hook up to the ground and just start injecting voltage into the output of the coils and see what's getting hot under a thermal camera. That would be my route to discovering what's shorted. And we do know that these boards go short. It's interesting that this is not shielded, right? We have 4 big coils over here, and these in turn supply our FCC component, our actual radio. So that's, I don't know, I would expect this to be shielded as well, but I guess it doesn't have to be. We do have shield on this one, and I tried to pry it open, and indeed it won't come off. So it's pretty big. So to remove this shield, I will definitely need to bend it a little, because there's no way I can remove it in one go. Is there a way to wick it? Let's look at it from this side. Well, not really. Not really. Okay, let's try this. Let's get a lot of other. Heat this up. I will put some cotton on those antenna ports. Just to protect it a little. I could also remove them just like I did the charging port, These are surface mount, and yeah, no through holes. These are completely surface mount. And looks like, how is it attached? Oh no, these are through holes. So it looks like the pins are surface mount, but on either side we have the ground that is a through hole, and I think it's soldered on because nothing is sticking through the board. Not sure, but let's leave them as they are. Let's remove these. Let's see, can we fix it here? Okay. Now, when I'm blowing, I'm going to be blowing from this side, right here, in this direction, which means this little fella will also get a little tape over here. So it just kind of slides over it. Hopefully it won't melt it. And we're gonna get a lot of air. 120 liters, that's maximum this device can deliver. And almost 500 degrees. Okay, I know I knocked out one capacitor over here when I was lifting it, and looks like I moved one of the chips in there. Let's see, this cup, no biggie. It's a big one, so it flipped from here, from this position, I think. Was there something here? Probably not. Oh, I completely damaged the board here. I was lifting too hard. That's why I wick it before I do this. This one I didn't, and that's the result. Oh, there's also, okay, that's why it was so hard. Okay, there's also pins inside. Alright, I wasn't hitting the inside of the shield high enough. I didn't know these exist here. Now I know. Okay, this chip, oh, it completely detached. Did we rip some pads? We did rip some pads. Okay, so that's not ideal. This would have been horrible repair if it was a repair. But now I know. And what do we have here? Is there anything that would cut shorts? Because if one of these chips cut short, they probably have some coating in them. So I probably wouldn't be replacing those. But we have... I don't really see anything here that would be catching shorts, or that is likely to get shorts. Just a whole bunch of chips. Okay, this is missing, and this is missing, but no, we didn't knock it off. It wasn't here in the first place. Okay, so if I had the exact same model, I would pry it from this side, because now I know there's no components there. Unfortunately, with this shield, there's no holes, so you have no idea what's underneath until you take it off. Oh, and we are on the... Okay, so once again, sorry, I keep doing that. Alright, this is our cap that we kind of knocked off. There is slight damage to the board as I was lifting from here, and that's the worst place to lift from because we have caps here. But surprisingly, I didn't move any of these. Right, we have the soldering on the inside, that's why it was so hard. Like this is ripped pad. I didn't heat up the center of the shield, as I didn't know it was soldered through the center here. Tiny resistors, better not to remove them, or accidentally remove them, because they are pain to resolder because of their size. Here's our chip, which has ripped pads. Alright, I even damaged it a little bit, so I was pushing from this side. I just pushed too deep. My tool went too deep. And probably the tool I was using was not the best. I think next time I'll just use something a little more steady or sturdy, and not pushing beyond this point, just in case. This could be reballed if the ripped pad, we have 1, 2, 3 ripped pads. If those ripped pads are not connected, and usually when the pad is ripped off, it's usually unconnected. This one is, but it could be, it would be easy to restore. Oh, this one is also ripped but connected. So that would be possible to restore the trace. This is some leftover gunk from the board. Okay. Yeah, so this would have to be rebuilt, and one trace would have to be restored, but the chip itself has a little damage over here, so this chip would probably go for replacement. It should be available. This little boy here. Alright, so there's not much under this shield, and I would expect that if this came for repair, I probably wouldn't even be attempting to take this shield off. Well, if the thermal camera shows that this heats up, it doesn't necessarily mean that there is a short somewhere here, because it's supposed to heat up slightly. After all, this is radio, right? So it's supposed to produce decent power, and if it communicates with satellites, it needs relatively decent power. So probably I wouldn't touch this one, but I was very curious what's underneath the shield. And I have a few caps over here for replacements should I need them, especially those big ones. They're pretty good, although probably I would think twice taking parts from this board, as the quality it's made is not the best. The quality of the components not the best, at least based on visuals. But let's see if we made any damage to the ports, the antenna ports, and nope, the Kaplan tape did its job. How about this one? No, it looks good. Alright, so, with a little bit better tool for lifting the shield, and with the knowledge that it's also soldered inside, it should be easier. Because I was only heating on the edges, because that's what I assumed was soldered. But there's plenty more soldering. That's why it was so hard. That's why it took so much time too. But it's always going to take a little bit of time, because you need to heat up the shield to the point where the solder flows. No way around it. So the entire board is going to be roasting. And only one cap on the outside that we touched. That we basically knocked off its position. Let's put it back just for the fun of it. Okay. I would put new solder on it, and not use the factory solder, or maybe just solder it right now after blasting it with hot air. Just put a little bit of solder here, and do the trick. Alright, so the cap is resoldered. The board looks not too great. You can tell that this was my first attempt by all the damage, and I didn't care too much. So that's probably reason number 2. I could have done it better, but if you don't know what to expect underneath, it's kind of hard. The first device, well, you kind of have to break to know how to fix it. Not always. Sometimes I work on the devices I've never worked with before, and I don't break them. But this one was definitely designed or designated to be broken, so I can learn how to repair them. So looks like there's not much else to it, gentlemen. Looks like this is pretty much it. So it's pretty simple. So one big MCU, the black box over here, and the power supply over here. Power supply number 1, 2, and 3. Right? Very simple. So if there is short, I probably wouldn't have too much issues finding it. And since most components over here are off-the-shelf components, this is very much repairable. Very much repairable. So good news. Oh, look at that. We lost a cap. Huh? This cap came from somewhere. And I'm pretty sure I know where from. It came from... not this shield. Here. Yeah. So we have one more. Or actually either here or here. Oh no, okay. This one goes here, and this one goes here. Like so. Yeah. Well, normally I wouldn't be doing that. But it happens. It always happens. Even if you work on the board for the 50th time. I keep doing that. Oh my god, sorry. Alright, this cap over here and this one over here. These are, we desoldered these as well, along with this one. But even if I work on a board that I've worked on a few times before, sometimes it happens. Your soldering iron just touches the cap as you work on this one. It touches the other cap and slightly moves it or completely desolders it. It happens. You know, you must always be ready to resolder components like that and to figure out where they came from. That's why I record everything, because it happens sometimes when I just find a component on the desk and I don't know where it came from. Then I review the footage and I know exactly where it came from and when and why. And that's why the whole idea of recording gives me, or the fact that I'm recording everything gives me the great ability to learn, because I can see exactly what I did wrong if something went wrong, and I always see what I can improve. So that's very valuable. And we did some damage over here, no biggie. The quality of the board actually is not too bad, but it has no markings, nothing printed on it. But all the components have values pretty much. Well, other than capacitors, obviously, but the capacitors don't need to be exact same values. Resistors do, but capacitors, no, usually no. In some rare cases. Well, maybe not rare. Some of them are configuration components, like on the PSUs, you have a capacitor that basically delays the PG pin by 100 milliseconds or 150, whatever. And if you replace it with higher capacitance, then the PSU, well, PSU will turn on, but the motherboard will say that the PSU is not good because PG went high too late. And the same thing if it goes up too early. But the board is absolutely repairable. I'm happy with that, because if you have one of these and the mechanic told you that all they can do is just remove the fuse to disable the board and order a new one, however much that might be, you might consider sending it over to me, and the short might be easy to find and easy to repair. I would love to work on one of these that actually is broken, because this one was not broken, so that was not fun. I wasn't looking for shorts or anything, but I would love to have one that is actually shorted to see exactly what was shorted. There's one more shield over here, but I don't care what's underneath it. It's right by the antenna, so that might be output stage of the radio. Although I would imagine that one of these chips are output stages, especially since these have the heat sinks. This one doesn't. So I don't expect this one to get hot. But that's pretty much it. That's all this device is. Alrighty, this is Subaru Forester 2016 DCM, which supposedly saves you when you had an accident somewhere where nobody knows where you are. The DCM does, and the DCM notifies someone to save you. So, relatively important device on your car, especially when you live somewhere, I don't know, Arizona, or otherwise middle of nowhere, and you don't want to get stuck in the middle of the desert. This device is probably something you want in your car. Alright, gentlemen, thank you very much for watching. If you have one of these broken, if you don't mind, send them over to me. I will repair the first one for free. No charge, just shipping cost, so around $25, $25 unless you opt for like really cheap shipment. You can send me the board only or the entire device, however you like, and I will try to get this fixed for you. Thank you very much for watching, and I shall see you guys in the next one.